Or do you think if I took Vaseline and like put it on my face, put coffee grounds on there, it'd be a good beard? Or should I like Sharpie it on?
I was gonna bring a freaking.
I know for Jared.
What happened to yours?
That is sharp. What are you doing?
Mr. Warren said yes.
This is my stuff. Tyler, you have to send some staff. Alright, there we go. Okay.
I can't see anything.
Hey. Alright, we're gonna be graphing calculators today, which I know you don't have, but I'm gonna show you how to use one in case if you go to a college level calc course, they ask you to graph stuff or plot points or do whatever different things you have. You need to be ready and easily be able to type things in so you're comfortable with that system. Because I know a lot of you have Chromebooks, you know how to use your smartphones, but in certain situations in like a college level course, they may not allow that. So you'd have to use the calculator that if they force you to buy one. Especially the math program is kind of strict about that. So, alright. So today, my goal is to show you how to use one of these.
Or do you have it? Is it required to take common knowledge?
No, I think you can test out, because if you guys are in this course, most people can test out math if they take the calc in high school.
Wait, you're smart enough?
Yeah.
No, I'm not. So I might not have to take that.
It's not very hard.
No, there's like a thing where like, if you get 20% or higher for your math section on the ACT, you automatically get a
I wouldn't know.
Okay, alright.
That's ridiculous.
Graphing calculator, we gotta make sure we talk about this and know how to type it in. Yeah, I'm gonna use my little broken one here. Okay. Alright, hey. First, let's do a quick review of the stuff we had yesterday, and we're gonna go in depth today on all the stuff. So that's why I said we're gonna do quite a few notes today. So the section we're in the next section, which is 1.6, 1.7, even though we're in chapter 2. Okay, consider this, we are a part of chapter 2 now. Because chapter 2 is based on graphing.
So we graph in chapter 1?
So, yeah, but I'm talking about like, we're going to be graphing some like weird stuff, curves, we're going to be drawing, not just sine and cosine, we will draw those, don't get me wrong, but we're going to be like looking at things called slope. Now, before that sounds stupid, but we're going to be drawing derivatives, which is slope for curved boundaries. So I know that sounds stupid saying that, but it's something like way more difficult than what I'm trying to express. Like I know that sounds dumb, like something you've done in high school, but I'm saying like the stuff we're about to do with like slope is super actually difficult. So I know it sounds silly, but I actually said it correctly.
Why are you laughing so
All right.
much?
Well, it's called a derivative. I know it's stupid when I say it like that, but
No, I get what you mean.
it's difficult.
I get it.
All right. So the first thing we want to do, I want to talk about all those different forms and the different shortcuts. Different forms and shortcuts for graphing. We started this yesterday, but today is the days where I'm not introducing it. We're actually going into it to make sure that you know how to do it today. All right, so we're going to start with kind of an easy problem, and we're going to work our way to kind of a difficult one. The first part that I want to make sure of is, do we know end behavior? That was something we discussed yesterday.
Just even power the cells in the direction.
Yep. Second thing we're going to talk about, we're going to talk about the intercepts. So intercepts, there's different ways to find x-intercepts versus y-intercepts. We're going to try to walk through that today. I'll try to do it kind of an easy one and kind of work our way up to more difficult. Third thing we're going to talk about, symmetry, how that affects our drawing. So we're going to talk about symmetry and know the formula and the shortcuts for finding symmetry. The fourth thing I want to make sure of.
Fourth and final?
No, it's not a final thing I want to talk about, just because of what we have. But the fourth thing is actually talking about turning points. Now this isn't the final thing we're doing today, but turning points is kind of like the end when you graph. It's like the last thing we always check. How many times should it turn directions? That thing. What I want to cover today is these main objects, actually go in depth into them. The one that we'll probably have to spend the most time on is intercepts. It's always the most difficult part. It's the one that takes the longest to do. There's other parts that we're not going to see today. I was going to wait till tomorrow, like horizontal, vertical asymptotes. So we'll talk about that stuff again. That's tomorrow. But the goal that I want to finish with today what I want to end with is I want to talk about how to do it on an actual calculator. And so show you my calculator, walk through the steps on it, on both problems we're going to do, because I have 2 problems set in my head that I want to get through today. Kind of an easy one, more challenging one. But once we get to the calculator stuff, that's the part where you just kind of need to watch, you need to kind of just see what I'm doing, how I'm typing it. There's not really a lot of notes you have to write down at that point, just because you just need to see it for the first time. Eventually, like I'm going to try to grab some of the calculators I have in the back. I have just like a junk drawer, just kind of full of old ones that were left over from previous years.
I have a question. Are we going to get homework at all this week?
Probably one assignment this week. So,
what day this week?
I don't know. I'm thinking maybe Thursday, maybe.
Thursday do Tuesday?
So, yes, no.
Thursday do Thursday?
So,
Thursday
all right,
do
but
October 23rd.
no. All right. So, well, let's do the first thing. Let's talk about NBAver. I'm gonna start with an easy problem so we can like easily check it. So, first part here's your function that I like to draw today. Again, we're graphing functions. The definition of a function, just so you know, it's for every input there's one and exactly one output. So if I'm plugging a number into my formula, only one answer is coming out.
What is this called?
This is a function. We're graphing functions. Yep. So, so here's my first one. I said I'm going to start easy, and we're going to work our way to a more challenging one today. So we're going to start simple, just so we can easily check things. All right. So we have my function. It is a quadratic. It's a parabola. How I know that? It has a power of 2. So I know it's a curve of some form. Anytime you're going past a power of 1, like a first degree, now we have curves of some type. It's called a quadratic, or a parabola, if you will. But how we actually solve this, how you actually graph it. There's 2 ways to do this, especially when we get to this like X-intercept part. It's kind of more difficult. But how we're going to graph it, I want to look at end behavior first.
Going up.
So end behavior. So what do we say?
Going up.
Okay, so we've already noticed that this thing is going up in the air. Now, what do we mean by up? So, Sid, you said it. How do you know? You are correct.
The positive number for the front thing.
Okay.
Coefficient.
So yeah, the leading coefficient, the leading number out front is positive. So leading coefficient is positive. So it's going up. Now, the other thing we have to look at for end behavior, we have to look at the power of it. So the power of the end behavior is actually the thing that's probably one of the most important parts. It's actually a part we probably should have looked at before the 1. That was out front, the positive 1. And it's the power. Well, this is a degree 2 polynomial. Degree 2, second degree.
I already said that before we wrote this one. You said both ways going up.
Oh, I didn't even know those.
That's why I said.
Okay.
But you said they were both going in the same direction.
Okay, yeah, so tails goes same direction. I didn't even realize I said that.
Yeah.
Tails goes same direction, so. All right, that's the big part. Now, the reason why I'm why I'm stressing that, because if they don't go the same direction, now knowing that it just goes up doesn't apply anymore. Because if they don't go the same direction, one's going up, one's going down, so we have to think about that concept of which way does it go, or which tail goes where. So in this one, we know the tails go the same direction because of the even power. The even power tells me that. So power of 2, power of 4, power of 6, 8, so on and so forth. So we know the tails go the same direction. So on our picture over here, we can put tails going the same direction, like that. Now we'll change this here in a minute. Just because that's just a rough scale, like my tail's going up somehow. I don't know where, they're just going up. Okay, are we good with the first part, first check? That's usually the easy. Okay, second one. This one is where I said we're going to spend the most time today. There's so many little ways to do the second part. Number one way, if you can factor a problem, that's a great way to figure out intercepts, especially X-intercepts.
Do you think we could maybe factor this problem?
Yes.
I don't think we should.
So X-intercepts. There's little checks we do. You either try to factor it apart, which we can, if it's possible. Another way to do it is to do that, to do the leading coefficient. And leading coefficient and the constant test / constant test. And that was the trick that I was showing you guys yesterday with that really kind of overlord difficult problem. But we have that leading coefficient / constant test that we do to figure out how to find x-intercepts if like we were not able to factor this thing. And then the last way to do it, which is kind of really just cheating, is just setting up the table.
How's that cheating?
Because a table won't guarantee that you'll find an intercept. It'll give you like a rough approximation if they're not like unclean numbers. Like this one's factorable, I just picked it out because it was easy to do. But if you can't find an x-intercept, the table can point out where roughly they're going to be. So we'll try to explain that with maybe the second one. Okay. And this is more or less. I don't like to go to the table because it's just more work sometimes.
Could you like do a combination of the table and the
factoring or whatever.
The factors of the last one over
Yeah,
there.
the leading coefficient. Yeah,
Whatever that is.
those where we took the tail, we took the beginning number, and we factored apart. Yeah.
It's like
That plus table.
Yep. I think we called that synthetic division test.
Yeah.
Yeah. That's a part of this. Well, we're gonna do the synthetic division test. We use synthetic division or synthetic substitution, if you will. Okay, that's a part of that leading coefficient that tail. Okay, this is why the x-intercept is so difficult. That there's so many different options to help you out that it's kind of difficult when we get to actually drawing it, unless you have like a calculator. All right, now the last concept is we do have two types of intercepts. The Y-intercept is just the Y-intercept is probably one of the easiest. All you do is we're gonna do just a simple substitution. We're gonna evaluate the problem where x is 0. That's probably one of the easiest ways to do a function. Just plug in zeros for all the x's, find your y-intercept. It's one of the easiest concepts to do. It's just that's one where there's not really separate rules. It's just one rule. It's one of the easiest things we do. In fact, we could do that right now. Just kind of figure out where this thing's going. So if I plug in a bunch of zeros into all my x's, what's my y-intercept? 2. So if I plug in a bunch of zeros for all my x's, it's going to be 0 squared plus 3 times 0 plus 2. Because it goes, it's called synthetic substitution. It's not just regular substitution.
Is that the same thing as leading coefficient constant test?
Yeah, it's the same thing. I just consider it all in one. Okay, so it looks like we do have a y-intercept of 2. All right, now the problem is we didn't do any of the other checks for the x-intercepts. We can factor this thing apart. It's called roots factoring, whatever you want to call it. So to factor this thing apart, what do you get when you actually break this up?
X plus 1, X plus 2.
Good. X plus 1, X plus 2. It's a trinomial rule. You break up the x squared evenly, you break up the 2 in the back to be 2 and 1, that makes it 3 in the middle. Now, why we do that is because this is your function, and whatever these solve out to be, if they're equal to 0, that's called an x-intercept. It's called a root or a 0. There's a bunch of different names for it. But it's an x-intercept, a root, or a 0. So we're hitting, it looks like we're going to hit -1 or -2.
Wait, or and?
And. All right, both. And. Sorry. And. Sorry. So.
You spell coefficient. I like how it works. Coefficient?
Oh, I did.
Coefficient.
Coefficient.
Yes, and.
Alright, so everyone's OCD is going up. Alright, so we have my x-intercepts and my y-intercepts. Now we can definitely see what's going on here. If I want to like try to graph this, because now I have my x-intercepts done. On the next one, we'll try to do like the leading coefficient test and the constant test for this table. What? That's when we look at the multiplicity of it. That's a part of this x-intercept test, and especially when we get to like turning points and stuff. Okay, is everyone good with how we factored it?
Yes.
Now, one of the things that Drowsy said, if you didn't catch it, when do we know when it bounces or passes through? That's a part of the multiplicity test of factoring. So you look at the powers that are on the parentheses. The powers on my parentheses are 1s, correct? For each of the things when we factor it apart. We didn't have multiple items like multiple x plus 2s or anything. So if the multiplicity, if the powers are odds, these are odd powers, that means that we're going to pass through those x-intercepts. on the parentheses. If one of the parentheses, like we factored apart and one of the parentheses repeated twice, that multiplicity would be 2, because there was 2 of like x plus 2's, let's say. So let's say somehow you broke yours up and this is what you had on your problem. And you factored it apart, somehow you got it to this point. Well, you have 2 of these, right? So you can combine them and make 2 of them because they're the same parenthesis. Well, the multiplicity is a 2, that's an even. That means you're going to bounce off of that number when it goes across the x-axis, wherever that tail's going. But when it's odd, that's when it passes through. We have odds. So on our
how would I
graph,
write this in my notes?
you can write multiplicity test. You can write that. Here. So multiplicity test for factoring. Shh. Can you stop talking, please? Alright, so multiplicity test for factoring. If the power is even, you're going to bounce off of that number. So that's when you're actually looking where the tails are, where those x-intercepts, y-intercepts are, it'll bounce off the x-intercept. If the power is odd, then it's going to pass through. Now, there is a change here from last year. I don't know if I ever really discussed this last year. The bigger the power, though, let's say, instead, it's still even odds, we still consider that, but if it's like a power of 7, you're still going to pass through it, right? It's an odd power. But the bigger the power, the more flat it gets when it crosses that particular spot. It like flattens out all of a sudden, and then it dips if it's passing through. So it could be something like this. So if I know that I'm going to hit this point down the road, but it was a power of 7, it might be like really flat there when I actually cross through. Because that's the bigger the power, the more turning point that it has, the more of an exaggerated turn, an inflection point. If it's a very like small number, like let's say a power of 1, it's pretty much straight up and down almost. It's just going through at a nice clean angle. So if it's an even power, and so now we're bouncing off of this, but let's say the power was like the power of 8, so it's a bigger power, but it's still even. It'll bounce off of it, but it'll really flatten out when it bounces. So the bigger the power, the more flat it gets at that inflection point, or at that intercept, I should say. So we have my graph. We have done end behavior, figured out the tail's going up. We figured out the factor, so we figured out the x-intercept. So we already know the y-intercept because that was kind of easy. That test is simple. So symmetry. Is this thing symmetric or not? I want you just to see this when you first look at it. I can tell if it's symmetric or not by looking at the function without plugging in anything. Are all the powers evens on all your variables?
No.
Even on the back one, there's an x to the 0. They're not all evens, correct? So this is not symmetrical. They're not all evens. If they're all odds, then it's odd symmetric. So that's pretty straight. If it's even powers, then it's even like symmetric. If it's odd powers, all of them, then it's odd. But if it's a mixed bag of like this one is, it's evens and odds, it doesn't count. 1s, 2s, and 0s, that's evens and odds mixed together. And I consider 0 to be an even when there's no variable.
Oh, you do consider it to be. That's a controversial topic in math.
I consider it even when we do the power test.
But what about when we don't do the power test?
Yes.
Okay, because if there
what about
are 0 people and there are 0 cookies, everybody gets cookies.
Nobody gets cookies.
So that means it's even.
Okay, we're going on. Here we go.
I got no debate with someone about this.
All right. So it is not symmetrical across the y-axis and the origin. We can already see that it's not perfectly balanced. Even from the graph, we're not centered over the origin. We're not centered over the y-axis. You can see it's like shifted a little like left a little bit. What's going to happen here? And now all we have to think about is how many times is this thing going to turn directions? So we already did my symmetry test because we already know by looking at the powers and stuff that should be very easy. How many times should this thing turn directions? You take the biggest degree and subtract 1 off of it.
What?
So the biggest degree is 2, you subtract it, you get a 1. This thing will turn directions 1 time. It'll go from one direction it's traveling, turn direction and go the opposite way one time, in theory. So again, turning point test is you look at the power and subtract 1. So if I put this all together, I can get a rough graph of this. That I can, it's going to dip down, it's going to pass through my x-intercepts because they only have powers of 1s. It's going to turn direction 1 and go through the y-intercept and keep going. I'm expecting that my graph is going to look something like this. Now the only problem that we're going to learn throughout this chapter, when we start graphing like more complicated things, is this point right here. This min or max, this is a minimum on this graph. It's actually an absolute minimum. This is something we're going to focus on in this chapter. By the end of this chapter, you should know different ways of calculating that. And that's the tough part. That's probably one of the most challenging parts of this chapter, is that thing right there, because it's not simple. There's a lot of work to be had to do that.
Is that the slope that would calculate?
Yeah, it's actually, that is a part of the slope part, because slope derivative, that's what they call it, is a part of like where we look to where that spot should be.
Okay.
On a graphing calculator, the graphing calculator can automatically find that for us.
So we should just always use a graphing calculator.
It's really nice when we have one. It's nice to check answers and stuff. And that's what I'm going to show today. That's what I want to go
Are
through.
you gonna tell us the definition of minimum absolute? Right now.
Of absolute.
Of minimum absolute.
A minimum absolute is the absolute lowest point of the graph when approaching from the right and left side.
Making sure they survive. I'm drinking my own blood. I'm making it. For you guys. Please send pieces of hair back.
It's like pulled up by
I'm drinking my hair.
he's like,
Here's cinema.
Okay, so if you didn't hear that definition, I just gave Nicole. The minimum absolute, or the absolute minimum, however you want to say that, is the absolute lowest point. No other point will be lower than that on a graph when you approach it from the left and the right side. That when you can look over the entire continuous flowing function, that when you approach the left and right side of any spot, that point that I have my arrow pointing towards will be the absolute lowest. There could be other points in the graph, there's low points, but it's not the absolute lowest. But notice that what it says, you have to approach it from the right and the left. If you can only approach it from one direction, that is not considered an absolute minimum.
Where would you only be able to approach it from one direction?
It'd be like something where the graph starts and then kind of goes up. Like this spot is technically not, they don't consider it an absolute minimum. It is a low point of the graph, but it's not considered an absolute like minimum, even though maybe it does look like one on the graph. Because the absolute minimum, by definition, you have to go from the left and right side.
Who decided that?
It's just a definition.
what if this? What if the spot is right above that dot? Because technically you can come from the left and the right.
Ooh, that's a good point.
You mean if there's like a little spot over here?
No. Like you go point like 0.001 up from that dot.
Like right here?
No,
Yes.
on the line. On the line.
I'm sorry. I'm sorry.
This is like starting.
Why can you
Yeah,
not
but
like?
right
go
off
up
the
like
starting.
barely.
Like here?
Yes.
But
Then
now
wouldn't that be-
I'm approaching from the right though.
And the left.
You could approach it from the left, from the start.
Some graphs don't have a starting or stopping.
Oh,
point.
you're saying that if I went to like the left of that dot a little bit and to the right of it, just like a hair,
Yeah.
that spot would be considered a relative min, because you know the spot next to it's lower,
But you can't approach that spot.
but you can't consider it an absolute min.
Why?
Because you can't approach it from the left. It's just called
So, but then the one next to it would be the absolute, because it's the lowest that you can approach from
the
your
only
side.
time you define it as an absolute is when you can approach from the left and right. It's,
But you can.
Yeah, that's where mine's been
okay,
Did you guys eat all the spinach dip?
all right, okay.
Let's eat it.
Questions on some of the easy stuff so far? Okay, let's do one more, and we're gonna kind of go through this one kind of quick. I'm just gonna make it a little more difficult than this one. Not like crazy difficult like I did the problem that I did yesterday, but I want to try a different one just so we can see kind of the idea behind it.
Behind
Okay?
it.
Thank you. All right, here we go.
Coefficient constant test. Is that the most difficult
I've
part?
never used
Uh,
what's base.
Yes and no.
Yes. That's how in depth. Do you want to come see my notes from yesterday and today?
Stop that.
I didn't have notes yesterday.
You could have just gone on.
Do you have a strong
I don't
forehead?
think that worked quite how you wanted it to.
What was it supposed to do, Hannah?
Knock the ball off. Or not, voila.
This is just an inaccurate graph.
Because
There are a bunch of inaccuracies.
over here, it's sort of getting
What?
Does that work?
Mr. Ward, why did you do 128?
Wait, I kinda don't wanna,
Gotta pick some weird numbers.
No, there's too many
can I
combinations.
just not write this down?
How about
Tell you
256 and
what I think
0.5?
about it?
We're not using decimals.
They
What
end in
about
opposite
0.3 repeating and
directions,
3?
and they're,
You can take out x plus 4.
Step one,
Take it out.
opposite directions.
Do it.
Just to.
Yep.
How about 6.65,
okay, so does the positive and negative not matter in
Stop.
this situation?
So, opposite directions for the tails. Now, this is the part we didn't really discuss. This is an odd power. The tail on the right usually goes up. The tail on the
right?
left goes down. So
Why
the
is
right
that?
tail,
Unless it's negative.
right tail, yep. Right tail goes up. The left tail goes down. Unless, and say it again, Justin.
I don't know what I said.
Unless it's negative,
Oh.
then it would change to be the opposite. And you're absolutely right. If it was negative out front, he's absolutely right. That left tail would go up, the right tail would go down. So this is kind of what we're looking at. The right tail's going up somehow, and the left tail's going down. Okay, and again, this is just a rough sketch of what we're thinking it's looking like,
What we're thinking.
what we're thinking. Okay, number two. Now we have the tails done. We're gonna look at doing intercepts now.
Negative 128.
Okay, so number two, we work on the x-intercepts or y-intercept. So y-intercept, let's do that one first because that's kind of easy task. You're absolutely right, say it again.
Negative 128.
Good, because when you plug in a 0, he's absolutely right. 0 to the third, plus 0, minus 128, which is negative 128. So that thing's way off the chart. So I mean, it's way down here. Like, I'm just gonna say this is negative 128.
Should we try to factor it?
Okay, so what?
Yes, now we're gonna factor.
X plus 4.
57,613.
Hold on.
0.002.
You're correct for the most part.
Or
So,
is it x minus 4?
For the most part.
One of the two. I don't know.
that's one of the answers. All right, now, to factor this thing apart, since this is a cube rule, it's power of 3, it's a cubic function, you can do it by grouping method. If it was a quartic function, like power 4 or 5, you would have to do that test where you take the back number, break up, and that was something that you guys were saying, like, I don't want to break up a 128, there's too many combinations.
Could it be 57,613 to the times 0.00222?
No, stop. Alright, so there's a lot of combinations that we have to do that, but since this thing is a cube function, I should be able to factor it to find x-intercepts. Alright, so what I mean by factoring,
507.0000069.
okay, let's factor this thing apart. Let's see, do I need to restart the camera? Yep.
What do you think?
Are you refocusing that?
8675309 and
No.
.0001475.
Okay, alright, so when we factor, the first two items have an x squared in common. So, in fact, I'm just gonna factor it over here. X squared, I'm gonna pull that out, so I'm left with an x plus 8.
Whoa, whoa, whoa.
That's
How do you know you
doing
can
the
do that?
first two items, because I'm
You can't
doing this
do-
by grouping.
All your
Because
groups.
if it's a cubic function, you can
Yes,
do
I'll
this.
Yeah, that makes sense. And then you can take out negative 60.
Yeah, the back end, I can take out a negative 16 if it works. So it does, because I made sure of it. So I take out a negative 16,
Do what?
and when I factor a negative 16, I divide by negative 16, that's an x. Divide a negative 128 by 16, I get a positive 8.
Whoa.
What?
Ooh.
Oh, so
that's
it
gonna,
bounces at. Or no, it doesn't bounce.
doesn't bounce. So what we do
Never
is
mind. That's off.
we factored out the 16, we factored out the x squared.
Now take x squared minus 16 and then it's x plus.
Okay. Yep. So then what we do is we take the x plus 8 out back, because if you notice, both items still have an x plus 8 in common. So what I'm left with is whatever's left when I took that off, that's x squared minus 16.
What if both of them were x plus 8?
If they weren't, I would go back and double check, maybe I just didn't take out a negative sign, or maybe there was something else I should have taken out, like maybe a 2 instead. I want to try to make the 2 parentheses that's left here, I want to make them look the same if I can. If I can't, like you're saying, then I'm going to have to resort to going through all those division rules, like
And
break up the 128 and try to
So why are
figure
you
it out.
squaring x
That's
plus
not
8?
squared.
Okay. What?
Why are you
X plus
squaring x
8
plus
is
8?
Because when you
because
pull
of
out
the
when you
same
pull out the common factor, there's just one of those things out back.
Yeah.
It's like what I did here. I pulled out an x squared from both these because they both had an x squared. That's what I'm doing. They both have an x plus 8, so that's the item I take out back.
Oh, okay.
Okay. Yeah. That's a common mistake. People think that you have to take 2 of them. There's only one for each of them.
I know those things.
What is that? What is that?
Okay. Good. So
I said.
yeah,
I mean,
this
you heard me
thing.
say positive and negative before we even factored it.
Yeah.
That's
Wow.
So.
Go guess.
So this next part is the difference of squares. So x, 4 and 4.
Really easy.
So it's x plus 4, x minus 4, and then x plus 8. So it looks like my 3 factors are negative 4, positive 4, and negative 8. Now I'm putting or, it should be and. These are all my x-intercepts, or my roots.
Or you can actually set that off by commas and it's antecedent or whatever. So.
Okay, so those are my 3 numbers.
Phrases.
Okay, so when I graph these 3 points, these are where I'm hitting the x-axis. Negative 4, positive 4, and what is that? Negative 8? 12, 11, 10, 9. Yes, okay.
Wait,
So-
what is it? Positive 4, negative 4, negative 8.
Infinity form.
Alright, so at this point, and my tail's still going down this direction. Now what I have to look for is, am I passing through? Because I'm doing the multiplicity test, it looks like all my parentheses have powers of 1s, so I'm passing through all of them. So this is a pass, because all these powers are
This is
1s.
pass.
So
Pass or fail?
Pass or two-dimensional.
Pass or
Is this
fail?
class passed down now?
Oh my gosh, he just said pass or fail.
Well, you
Okay.
either pass or you
Now.
fail.
We are passing through these particular numbers, and that one Y-intercept is way down below, so we'll have to kind of dip down and try to hit that number. But the big thing is, symmetry, it is not symmetric when I first look at it. You can see from the graph, but it's a mixture of even and odd powers, so it's not symmetrical. And so now what I'm going to try to do is draw this. How many turning points should I have? 2. The biggest degree was 3. I subtract 1, so I should turn twice. So if I actually follow the graph here, it's going to turn once,
Twice.
so it'll keep going twice, and then it'll keep going, and it'll go up through. So,
You have to connect that line.
To infinity and beyond.
oh, see, he's going up.
You're only gonna hit the one.
Yeah, I know, it's really bothering me how you didn't hit the.
There you go.
Can you just move the.
Wait, don't you think that would be
Mr.
hard?
Roberts, you consider that line going to infinity and beyond?
No.
What do you think the domain
Okay.
of that line is?
Alright.
Rails?
Now, is everyone comfortable with like the main stage of what we learned here today?
Oh
The
my
goal
goodness.
tomorrow is we're going to look at that one where when you have to break it up, you can't factor it, so you have to find numbers. Okay, the next part.
That's
You can
Oh,
put-
wait.
mighty
You
difficult.
can put these graphs away in your notes. I want you just to watch what we're going to do with the calculator.
Just watch it, don't do it.
Mr. Warren, what have you done a vaping
We don't have
epidemic?
a problem.
What did I have?
The what?
Hey, did you see that?
Ask Kaminsky.
See right away, it's my correction. Can you put those in?
Hey, yeah, you accidentally gave me 65% of my test.
I bet you.
You accidentally put 65% for my test instead of 90.
Oh, I tried hard.
Instead of
Just give me
9.
100. I didn't realize that.
Mr. Ward, did you put it in the grade book?
Did you misplace this? No, he didn't.
Today I
You
will.
misplaced
What do you have for the grade book? Tomorrow.
it.
Would you like my very hard taking notes?
Oh, Jay, can I have a pretzel?
Mr. Ward, is it just a stamp packet?
Okay, fine, okay.
Is that actually going in the grade book?
No, it's going.
Do you want me to dispose of
Okay.
that?
Going in the grade book?
All right.
Scared hat.
Okay.
Let's do like, yeah.
Oh,
Okay, I'll you. Thank you.
JP,
Thank you.
Can I get in the bed? Can I get in the bed? Can I get in the bed?
Oh, that's my feet! That's disgusting! I was like, wow, that's some ugly feet up there. I just ripped.
Okay. Hey.
I was
This baby's gonna be
All right. So we're gonna go through the concept of how to do this on a calculator. So I'll kind of push the buttons as we go. Turn it on so that bottom left corner. Okay, so now, all right, so it's on. Sorry, I have a cracked screen on it, but okay, what I would like to do in that upper left corner has y equals.
It was fingernails.
Okay,
Stop
so
it with your ugly hands.
okay, what we're gonna. I've already typed in that first problem we did today. Okay, so I already typed in the first problem we did. X squared plus 3x plus 2. Now to type that in. The X button, so you can see it. The X button is right here. It's right next to the alpha key. This has a bunch of variables. It has X, a T, a theta, some other variables. It's just, every time you hit it, it's always just an X. So when I typed it, I hit X, then I typed a little caret symbol and typed in 2. That's the power. Now on a newer calculator, you'll have to put that in parentheses. Just because, okay, stop.
That's
All right.
2.
Yeah, but you'll have to put that in parentheses because the newer calculators expect that if you're still writing, that all the stuff you're still typing goes in the power. Mine's very, very old, so the idea is that we had to make sure that on mine you don't have to do that. Okay. All right. Now, what I'd like to do next, Nicole, is hit the little window key. The window key is like in the middle, like somewhere right. Okay. The window key is what you can set your scale for your drawing. I'd like you to type in a -12 for the X minimum. So that's like on a graph, mine goes to -12 up to +12. So you go to the next number down, the max is 12.
We use these instead.
Yep, we go down to the next line, it goes by ones, we're good. Keep going down to the Y's now. Y minimum, go -12.
Why not -128?
We can do that later. We'll go to 12 and we'll jump by ones. All right, now, once we have that window set, hit graph.
Hit the gap button.
At the graph. Okay, so this is kind of a rough picture of what our graph will look like. Now, this is the first one, mind you, not the second one. This is the first one.
That's an exact
So,
picture.
now, because the second one we did had the 128, we didn't need to go to 128.
You can get it on the x-axis a little bit more, I can't see.
There you go. All right, so, now, you don't need to go that far. All right, so, the calculator can actually zoom for you. So, if you want to go hit the zoom button, there's a zoom button right here.
Where? What's happening? What? I presume.
Somebody took a photo. All right.
Who did it?
All right, now.
Is it Houdini? Is he in here?
So, if you go up and go to the zoom in, that's the second option, hit enter. It'll automatically zoom every time you hit enter. And it'll try to stop there, don't go any further.
Oh god.
It'll go to a point where you can actually see the graph, you can move it around with the arrow keys, but it's really slow because again, these are very old calculators. But if I want to find that minimum spot, hit the calculate tab. It's right here. So you'll have to hit the shift, and then hit calculate. It's right there. And what? Oh, we got to hit shift first.
I did hit it.
Shift, calculate.
If you hold it down.
So see, it has a little up button right there.
I wonder if you have to zoom out.
Zoom out.
I wonder if you have to zoom out. I do this. You guys watch over.
I'll do it.
No. Alright.
I will.
Now.
I was actually pressing buttons. I know, and I was just waiting. No, it's sideways now. We don't like it.
Okay.
Give it here. Come on.
Now.
That is unacceptable.
Sorry.
Oh god.
Hey!
No, I could not. It's so ugly. On my feet.
Oh,
I'm so disturbed too.
I'm just her timing.
Ray Rowley, Ethan Coogan, Caleb Wall, come to the office.
The picture of this smile at.
Jordan, I just wanted you to have a picture of yourself.
Oh my goodness.
Did you get your pictures that I sent you yesterday?
Yes, I did. Thank you.